So hi, for those of you who don't know me, though many of you in this room do know me, I'm Kaitlyn Dionne, and I'm the program head for the analytical Sockeye and Pink stock assessment program with Fraser and Interior Area with DFO. And I'd like to start my talk by acknowledging that, although I'm currently the one who facilitates this work, this has been the culmination of many, many years by many people to get us to where we are today. And so I'd just like to acknowledge many of you who are even in this room. So first of all, I'll start off with just the why do we forecast? Well, first of all, it's mandated under the Pacific Salmon Treaty, and it's used for preseason planning for fisheries management involved in the bilateral fish management process through the Fraser River Panel, as well as our domestic processes through the IFMP, the Integrated Fishery Management Plan, Food Social Ceremonial, and EO Fisheries for First Nations. And it's also useful for my colleagues on the operational side of stock assessment as far as determining staffing, appropriate levels of staffing, what equipment we should be using, and what methods we should be using to enumerate our populations for the year. So we do preseason forecasts for 19 major stocks and then 6 additional what we call miscellaneous stocks, but they're essentially smaller stocks that we don't have good enough data to do do better stock recruit modeling on. And these stocks are divided into run timing groups or management units based on their timing through which they return to the Fraser. So the first run timing group or management unit we have is the Early Stewart, and they are one forecasted stock, and they return all the way to the very upper reaches of the Fraser River watershed. Then we have the Early Summer management unit, which consists of 7 forecasted stocks and 3 miscellaneous stocks, and they're kind of scattered all throughout the watershed. The third management unit is the summer run timing group, and this consists of 6 forecasted stocks. These are usually our major players consistently year through year. This includes Chilco, Quesnel, Lake Stewart, Stalaco. And then finally we have the Lates, which includes 5 forecasted stocks, 1 miscellaneous stocks, and the Lates have historically driven the total Fraser salmon abundance on the dominant cycle line through the Lake Shuswap stock. And then the rest of the Lates kind of spawn in the lower Fraser. So there's a lot of data that go into these models. So we have biological data, which includes our returns at age to get our recruitment, our escapement, which we boil down into effective females, which considers the sex ratio in addition to the percent spawn. So that kind of gets at a bit of the pre-spawn mortality and sex ratio instead of just looking at spawners as a total. We also have some juvenile data that we can incorporate into our models from our smolt fences at Cultus and Chilco, and as well we get some data from the Salmon Enhancement Program for the channels from Nadina and Weaver, and as well we get a fry estimate from SEP from the Pitt River as well. So this is kind of what our very long time series of data look like for the Fraser. So it goes back to about 1950. And the dark teal bars and dots highlight the 2025 cycle line that we've forecasted for this year, and the light blue and the gray are the other cycle lines. So we can see from looking at the productivity graph on the bottom that we had kind of a long period where we had fairly high, stable productivity, and then about 30 years ago, things started to decline, and then you see this period. We're kind of in this period of very high variability. So we also include some environmental data. So we look at the Fraser discharge, the average and the peak at the time and during the year that the smolts are leaving the Fraser and heading to the estuary, as well as we look at nearshore sea surface temperature covariates from Pine Island and Entrance Island. We also consider the PDO to look at the offshore temperature information, And we've recently started looking at Pacific salmon abundance, but this is kind of, we're just waiting to see a few more years to see if it can be really informative to use this covariate, but we're paying attention to that. So then we take all of this data and we run it through some models. So we have 23 different Bayesian models available, and we can add more by adding more covariates and trying to and do this. But we have they consist of the naive models that E already alluded to, that she talked about. And these are like time series averages, averages across cycle lines, average recruits responder rates. They're not using any sort of biological relationships. And then we have biological models like Ricker, Power, and Larkin, and we use sibling models for H5, specifically for stocks that they perform well, where there's a good relationship between 4 or 5-year-old returns. And as I said, we include some of those environmental data that we alluded to earlier, as well as some cycle line covariates. But with so many models to choose from for all of these different stocks, how do we choose which model or forecast for each stock? And well, first of all, we have a retrospective analysis, and this was updated in 2021 for the 2022 forecast, and it uses a one-step ahead approach, and it ranks the models based on the various metrics that you would consistently see in a retrospective analysis. We get a table of model rankings. But what's unique to the Fraser is we also have a meeting every December to go over stock by stock with expert opinions. So we sit in a room with members from the Fraser River Panel Technical Committee, which include First Nations, US representatives, DFO representatives, and we all sit in a room for, it used to be 2 full days, but we've managed to get that down to a little bit over a day, and decide which model makes the most sense. And so we use a process of initially, so I'll walk through kind of Yi developed a really lovely forecast viewing tool, and so we kind of go through this iterative process by looking at these Taylor diagrams, which I'll have a slide of next to show you, which allow us to kind of look in graphic space how models perform relative to one another, and it kind of helps us to guide our discussion when you're looking at a big, long table of ranked models to kind of help you decide figure out where you should be focusing your conversation. And then, of course, we have many retrospective tables that we can look at for age-specific, overall, cycle line, and what has been done previously. And then we also can look at what did we do in the past? Which model have we used historically? Did it over or under forecast consistently? What does it say? And probably one of the most important things is, does the model, the productivity implied by the forecast model make sense given our current observations? So if the forecast comes from a model that's highly ranked, but the productivity is kind of the implied productivity is well outside of the bounds of what we've historically seen, then that to us suggests strongly that that model likely doesn't make any sense. And so this is just a screenshot of what the forecast viewer looks like as an example. So here you can see the Taylor diagrams. And so each dot represents a model, and you're trying to get as close to this dot in the bottom for the, which is the observation. And so the further down on the plot it is, and the more in the center, the better the model performs. And although this doesn't consider all of the metrics that a retrospective ranking table does, it is a really useful tool to help us decide help us kind of guide on which models are kind of making the most sense. And then each of these blue dots here is a link you can click to flip between tables quickly to look at, if you want to look at one model versus another and how they perform across the various metrics. And then there's other plots that you can look at as well. And so we do that for all the stocks, and then we end up building this table. So because we do it as a Bayesian model, we take the 80% probability interval, and we give the values across all of these. Most people pay attention to this 50% column, which we call the P50 forecast. And then they're summed across the management unit level and then at the to the total level. And this is the table that management uses year after year. And this is the 2025 forecast. So this is just showing, just to highlight for when I present this to other people, what to look at if they're not interested in a specific stock. And you can see all the different model choices that we came up with that happened this year. And so how do we do? Well, it's variable. But in general, so the yellow in the middle is it's kind of closely aligned with the P50. Anything to the left is highlighted as below expectations, and then anything in green is above expectations. And I'd really like to highlight that you can see this period from 2015 to about 2020 where we had consistent model performance issues, and this was really, I think, due to an out-of-date retrospective analysis. And so once we got an updated retrospective analysis, we can see that the forecast performance has drastically improved. So I think evaluating model performance across a more relevant time frame is critical to be getting these, trying to get the forecast as right as possible. And that's all I have for you today.
Now, do you want to take questions now, or just wait after every the other?
It's up to you. I can, if people have questions now, I can ask questions.
Well, does anyone have an urgent question they just want to get out right now? Carrie.
I'm just wondering that reevaluation, that retrospective analysis, is that how often do you anticipate doing that?
It is not set in stone, and I'm currently working with Mike Hawkshaw and Adam Kaiser and Catherine and trying to figure out what an appropriate time frame to solidify how often we should be updating our retrospective analysis is. The thinking has been that we have to go through CSAS, the Canadian Science Advisory Secretariat, which makes it kind of a big thing to do, but I think if we can just publish it in a peer-reviewed journal, we can probably do that and avoid the rigmarole a bit. But yeah, we're trying to figure out an appropriate time frame to reevaluate the retrospective analysis right now.
Following up on your last point about time frame, are there any populations that are thought to be changing recently, especially more so than others, in the sense that historical data won't necessarily be as good a predictor in the coming years?
A lot of them, I would say. Nadina particularly is kind of going the opposite of everything else. It's kind of the bright light in the Fraser right now, where it's kind of trending up, where a lot of other things are trending down. But we've also kind of gotten into this phase of forecasting across many stocks where we're at or near the origin of the stock recruit curve, which is making the forecast extremely uncertain because the populations have been so depressed, especially on the 2024 and 2023 return. So, but yeah, it's variable, but some are going one way, some are going another, but yeah.
All right, thank you very much, Kaitlyn.